Hi there. Today we're going to be talking about rational numbers and how to work with those. We're looking at some decimals, some fractions, and mixing things back and making things go back and forth between the two. So here we go. Let's take a look at the first example here. It says write 3/4 as an example. As a decimal. So remember, 3 over 4 means the same as 3 divided by 4. So in that case there, we would simply take the 3, it's a number on top, and we're going to divide it by 4, putting it outside the house there. And it means we're going to put a decimal there, put the decimal on top right away, and just simply do some division to figure out what that's going to be equal to. So 4 goes into 3 0 times, 4 goes into 30 7 times. So 7 times 4 is 28. We subtract. We bring that down to 2, bring down to 0, and 4 goes into 25 times for 0.75. Again, you can do a lot of this with a calculator, but the goal is to see if you can do it without the calculator. That's kind of the idea. Okay, so sometimes as a fraction, we're just going to use it as division to turn it into a decimal. Okay, other times you're going to have ones, but watch your sign, where you don't want to watch the negative or positive, and then turn that decimal into a fraction. Now with decimals, remember that your decimals, you have the decimal place, and then you have the tenths is your first thing, followed by the hundredths, followed by the thousandths. So if you're talking about place value, if I have 0.1, that's 1/10. If I have 0.01, that's 1/100th. If I have 0.001, that's 1/1000th. So make sure you got your place values the right way. Now, when you're looking at this number here, I look at the second digits, so I don't look at tenths, I'm going to look at the second, and I would have 16, I'm looking at two digits there, 16, and the place value here is hundredths. So I write that over 100 is the idea. 16 hundredths there. So if it was just a 0.7, right, then I would say that is 7 tenths. Okay, so those are 7 tenths, this is 16 hundredths, and because it wants it in simplest form, it does mean you're going to take that number and then reduce it down. And you can see they reduce it down, dividing everything essentially by 4. 16 divided by 4, 100 divided by 4 gives you 4 over 25. Not forgetting, of course, that it's negative, and so it remains negative the whole way through for a negative 4/25. Okay? So do be careful there, but make sure that, if I had 70.72, that's going to be 72 100ths. If I had 0.5, that's going to be 5 tenths. And I can, of course, reduce that down to a half. So, and I can reduce that one as well. So just know your place value for how that works. Number 3 is a good example of what we do when we have a repeating decimal, and we're going to write it as a mixed number in simplest form. So they give you a little kind of strategy here for how to solve this. So let's talk about how this works. Let's say I have 8.2. We're going to just create a variable, is what they're going to do. We're going to say that n equals 8.22222, just running on forever and ever, representing essentially that part there. And then we're going to set up an equation. All right, we're going to say that 10 times n equals 10 times 8.222, right? That whole craziness there. Okay, we're going to do this because why? Well, we've decided that n equals 8.22. So I end up with 10n. So let's subtract the value of an n from both sides. Well, first of all, I should multiply this out. Sorry about that. This becomes 10n equals, and multiplying this by 10, you end up with 82.222. The reason we do this is we have the repeating part still continuing on forever and ever. So now when I subtract an n from this side, and my value of n over here is 8.22222, what this does, and again the number 2 doesn't matter, is I'm eliminating all the repeating decimals by giving n the value of the repeating decimal to start with. So 10 minus 1 is 9n, and that's going to equal 82 minus 8, which is going to be 74. So in doing this, what I've done is I've said, let's just make up a value for n. And I'm going to say that n equals my crazy repeating decimal. And I'm going to make a little equation to say, well, what would this equal if I set up an equation? So now I can divide both sides by 9, and n is going to equal 74 ninths. Well, 9 goes into 74 8 times, with 2 left over for 8 ninths. So in doing this, what I've said is I can turn that crazy decimal into a fraction by turning the repeating decimal into a variable in and subtracting that from both sides after first multiplying both by 10. So there's a little bit of a step here. We have one in our samples we'll do together, and you have one of these in your homework to do together too. So it's kind of a fun little problem, just a little bit of creativity to get that solved. Let's look at some samples and see if you're kind of getting it. So the first one here, 2/5. One thing I like to think about here is I have two ways of approaching it. I could do 2 divided by 5, right? That works just fine. And 2 goes into 4, 5 goes into 2 0 times, 5 goes into 20 4 times, and I'm fine right there, and I'm done, 0.4. Another way of thinking about this, though, is to say I can get this in terms of tenths. Think about tenths or hundredths. In this case, if I think about tenths, I know that if I multiply the top and bottom by 2, I get 4 over 10. And once I have 4 tenths, then I know that it's 4 tenths written as a decimal, just like that. I could do the same thing with hundredths as well. So this one here, for example, is 3 tenths, so that's easy enough, 0.3, right? 0.3, and we're done. If I want to think about it as hundredths, which I don't need to, I'd multiply both by 10, and that gets me 30 over 100, which is 3 hundredths. But again, I wouldn't need the 0, so it's 3 tenths really. Okay, but you can look for ways to multiply the top and bottom by a number so that you end up with a 10 or 10 or 100 on the bottom. This one I can't do that, so I'm going to have to simply do division, right? So I would do 7 divided by 8 and then work that out there longhand. Okay, looking at one like this, I can say, well, the 2, that's going to be easy enough. That's a 2 point something. 16 over 25, I recognize that this is something that I multiply both sides by 4, or top and bottom by 4, I end up with 16 times 2 is 32, 32 times 30, 32 times 2, well, yeah, let's go 16 times 4, let's do it this way, is 464 over 100, so that becomes 64 hundredths, so it's just like that. Okay, so sometimes you can just see little ways of turning your denominator into 100, and then you do the same for the top, and you can rewrite it there. Okay, this one here is going to be repeating decimal, right? Because 2 divided by 3 becomes 6, which is 18. Bring down the 2, and it goes on forever and ever. So you end up with a repeating decimal of 0.6, but don't forget that it's negative. If it's repeating, I put the repeating sign right over the top, just like so. Alright, and then let's take a look at this guy here, same idea. Here I have -4, it's going to be right there, but then I need to do the 3 divided by 11. So here's 3 divided by 11. 11 goes into 30, well, say 2 times, 22. Subtract, 11 goes into 87 times, or 77, and then we're back to 3, and we're going to get a repeating decimal there. So we have a 27 hundredths, and don't forget it's negative for something like that. If you're writing as a fraction, some pretty straightforward. We have 8 tenths here. This becomes negative 15 hundredths there. And then we have one of these again. What we're going to do is we have to do a little bit of math, right? We're going to say that n equals 1.777, and then we'll set the same equation. So here we go. We're going to say 10n equals, let's multiply this by 10, equals 17.777. Okay? Now we're going to subtract the value of n from both sides. N we said was 1.777. So that we have 9n equals 17 minus 1 is 16. So n equals 16 over 9. 9 goes into 16 one time with 7 left over. And that's my solution. 1 divided by that. And you take a look at a calculator. If you did 7 divided by 9, what do you get? 0.777. That's that run-on. So there's our 1 for a whole number, and there's our 7/9, which is 0.77. Okay? So that's it for the directions. You get the homework today, which is about the odds, so good luck with that, and we'll see you back here to check them in just a minute. Okay, here's our odd solutions for today's homework with rational numbers. So 3/5, I would probably recognize this as multiplying the top and the bottom by 2 over 2, so that I get 6/10, and I rewrite that as 6/10.6. That's the easiest way for me to see how to do that one there. This one, same thing. I'm going to multiply by 5 over 5, so that my denominator becomes 100, the top becomes 45, so 45 hundredths is written like that. Okay, again, you could also divide, and that's just fine too. Here, I'm going to need to divide, so 11 divided by 16. Don't know what that is with the decimal there. So 16 goes into 110 about 6 times. So we have 6, 36, and then we have 9. We subtract, and we have 14 left over, bring down the 0. 16 goes into 140 about 8 times. So 8 times 16 is 128. I'm going to subtract that, and we end up with 12. Bring down a 0. 16 goes to 120. Oh, good old 7 times. 7 times 16 is 112. We subtract, and we have 8 left over. Bring down another 0. This keeps going. And 16 goes into 80. 5 times 480. So we're finally done there. So there's number 5. Whew, that was a long one. Calculator's nice for those, but here it is. Number 7. The whole number stays at 3. And then down here, if we multiply this by 2 over 2, we end up with 2/10. So this becomes 3.2. Number 9. 5 divided by 33. We have a decimal, decimal, decimal. Decimal on top right away. Okay, so 33 goes into 5 0 times, goes into 51 times. For 33, we subtract, and we're left with 17. Bring down the 0. 33 goes into 170 about 5 times. 5 times 3 is 15. Carry the 1, 16, and we have 5. Bring down the 0, and we can see we're back to 50 again. So what am I going to have? I'm going to have a repeating number. It's going to go like this. So my solution would be 0.15, and put the repeating bar over the 15 because it's going to repeat and repeat and repeat. Number 11. Okay, that's going to stay out in front, -8, and now you need to do 11 divided by 8. Okay, and when you do 11 divided by 8, you end up with 0.61, and the 1 repeats forever and ever. Number 13, we have 8/10. Right? It's negative though, so we write -8/10. I want to simplify it. I can divide both sides by 2, or top and bottom by 2. 8 divided by 2 is 4. 10 divided by 2 is 5, so I have -4/5. Number 15, I have a -1, don't forget that. And this is 35 hundredths, so I can write it as 35 over 100. That can be simplified, because 5 goes into here 7 times, and 5 goes in there 20 times. So I can reduce it. Number 17 is one of those kind of different ones, right? So we're going to say that n equals, and for now I'm not going to worry about the negative. Don't worry about it until the solution. I know the solution is going to be -1 something, right? So I'll worry about that later. So n is going to equal 1.555. So we're going to say that 10n equals 15.555. Oops, forgot my n there. Subtract an n from both sides. The value of n here is 1.555. So that 9n equals 14. N equals 14 over 9. Right? And so we have 9 goes in there 1 time with 5 left over. So 1 5/9. So -1 5/9 is my answer there. Number 19, express the fraction for Asian as a decimal. Okay, so I'm going to turn that into 100 by multiplying top and bottom by 2. So I have 2 over 100, which equals 200, so 0.02. African American, I'm going to multiply top and bottom by 4. So I have 100 on the bottom. 4 times 4 is 16, so I have 16 hundredths. And this one here, I'm going to multiply by 2. So I get 2/10 and write it as 2/10. Again, I could put the zeros in front for these if I want to. It's all the same. All right, that's it for today's lesson. Hope you have a great day, and we'll see you next time.